Question was asked in IIT-JEE main exam 2023. A source supplies heat to a system at the rate of 1000 watt. If the system performs work at the rate of 200 watt, the rate at which internal energy of the system increases. So the question is, we have some source, that means the heat supplying source, and from that source to system, basically system which do some work. Okay, so from the source to the system we are providing the power in the rate of 1000 watt. Okay, if the system performs work at rate of 200 watt, but the system performs only the 200 watt of power, the work is only converting into system converts only 200 watt of work. Okay, that means the remaining is used to raise the internal energy of the system, or it is utilized to do some internal works. So therefore we have to find out, right? So in this we have to find out how much the internal energy increase will takes place if under this condition, right? So we have four options. After solving this question we have to find out the right answer. So from the first law of thermodynamics, right? So from the first law of thermodynamics, whatever the heat, dq is equal to du plus dw. That means the total heat given to a system is utilized for two purposes. One is to raise the internal energy, other one is to do the work. So what we have now, we are giving some heat, that is total heat. So we have to find out du, right? So du we have to find out. We know that how much work is doing by the system, or work is done by the system, right? So what we'll do, this first law of thermodynamics we will modify a little bit in order to use it for this problem. Okay, so how will you modify? We know that the rate of change of heat energy is equal to the sum of rate of change of internal energy and the rate of change of the work done, right? So that in the form of equation we can write this first law of thermodynamics as follows, like this. That means dq by dt is equal to du by dt plus dw by dt, right? So we have written now in the form of rate of change of the heat with respect to time, and rate of change of heat with rate of change of internal energy with respect to time, and rate of change of work done with respect to time. So we know these two rate of changes, right? So that means the heat supply rate we know, and also we know how much the work done is extracted from the system for a given supply of sources or given supply of heat energy. So but we have given some total heat energy, some part is converted into work, but remaining part is utilized to raise the internal energy. So this raise in internal energy we need to find out, right? So we know that dq by dt is 100 watt, right? Source supplies, that means we have some heat sources, that heat source supplies some amount of energy to the system to do some work, right? So that is dq by dt is equal to 1000 watt, and we know how much it is performed, the work is performed by the system, that is dw by dt is 200 watt. So we should calculate du by dt is equal to what? So now dq by dt is equal to 1000, which is equal to du by dt we don't know, plus 200 watt, right? 200 watt, that is dw by dt. So now du by dt if you take, so and take this 200 to the left hand side, what we will get? Du by dt is equal to 1000 minus 200, right? So that into watt. Therefore du by dt is equal to 800 watt. That means the rate of increase or the rate of change of the internal energy for this particular condition, under this condition, is 800 watt. That means the remaining heat is utilized to raise the internal energy of the system, that is about the 800 watt.